So this time, FalconEye Blue Team Challenge. So again, this is another Splunk challenge. So FalconEye. Okay, so first up, you have to download the package because this is a virtual machine with installed Splunk and data on it, just the data regarding the challenge. So yeah, the password is this one. And as for the overview, of course, this is the credentials for the VM. And to access it, you have to spawn up and start the virtual machine. And actually, the port is port 8000. I'll show you later. Okay, so overview of the challenge. So as a SOC analyst, there's a breach in the Active Directory. And what's interesting here is that the attacker launched a dsync attack. So to compromise user accounts, utilize also patch-dash attack. Alright, so this is a very interesting diagram of the attack. Okay, so let's spawn up our VM. So actually it's already here. So I have set it up with my VMware workstation, spawn it up and use the credential vagrant. And to access it, actually you need to access this using port 8000 and you will be brought here. So all good, we can now start the challenge. What is the name of the compromised account? Okay, so we'll now work on the data that we have on the from the VM, Splunk VM. So yeah, if you're not familiar with Splunk, so this is very intuitive. So you could start with the asterisk, or let's search what index are available. So we could use their stats count by index. So just so sort of know what index or collection of data is available for us. And as we can see, we only have folks index or database collection of events with 254,000 events. So we can now use it. So index equals folks. And by the way, gleaming through this challenge, we could actually see number 6 is quite a giveaway here. So I'm cheating a little bit. So we could use fun.exe in our keyword just to fun.exe, just to narrow down our search. So because the one that attacker used, and with this we could actually tie what user is compromised. Alright, so it's narrowed down to 38 events from 250,000 events, and let's see what users in Splunk. It's trying to aggregate all the parse fields here. These are all the parse fields, and you could actually view more. This is the field sidebar, and what's interesting is that each field it shows you the aggregated data. So here we have user, only 2 user, and what do we know here? Of course, this is a system account, and this is our compromised account. So usually, attacker goes for help desk account, right? Because it's everywhere. It's logged in everywhere in the system. So no surprise there. That's actually how we found this. All right. And now, what is the moving on to number 2? What is the name of the compromised machine? So for this, so let's add. So to add a search term, you can simply click here, and this will be automatically added to our search here above. So now we are tying up the tool the attacker used and then the compromised user, and that using that we'll find the compromised host. So if we click here, what do we know? We only have client 02 here, and that's how we found the answer. Oh, sorry. Client 02. Alright. What tool did the attacker use to enumerate the environment? So this is again a fun and interesting one. So again, let's now limit our search to client 02. Okay, so I added it in the search term. And as we can see here, if we are dealing with enumeration, Okay, let's remove the help desk. Okay, let's focus entirely on the compromised host. And actually, this is still a very broad search, as you can see, 1,500 events. So to limit that further, when we're dealing with enumeration, you have to be familiar with PowerShell PowerShell script block. So this is commonly used by attackers to launch malicious commands by PowerShell. Sometimes it's encoded rather, encoded command. So you have to know and familiar with the event IDs for that. And as you can see here, script block event IDs. There are two popular script block event IDs in PowerShell. So the one is 4104 and 4103 actually. As you can see here, it's mostly the results of our Google search. And 4104, so you have to familiarize with that. So yeah, I have here my history. So if we limit it 4104, okay, and let's change it to the list so that you could see. So actually, you will find here some interesting events. So script block text. Okay, so I'll get straight to the point. So one of the popular message, what you call this, message total. Okay, one of the popular enumeration tool using PowerShell is what you call the Bloodhound. So somewhere around here is the Bloodhound result. So I'm just using. Okay, let's move back to, let's increase the results per page so that, and then let's do a row so that you could see. We actually quite a number of results, so hang on. Alright, I think I missed something. So yeah, actually the script block text, we could actually add it in the result. Script block text, so these are the contents. So I know that's a lot, so let's do a stats count. Stats by script block. There you go. And message total, so that we could sort it. Message total. Alright. Okay, so I just have it. So the message total is right here. So we could sort it highest to lowest. So now we are sorting it. Okay, let's give it some time to load. Alright, what happened? Okay, now it's sorted. Is it sorted now, highest to lowest? Yeah, indeed. Okay, moving back. And now moving back. So if we scroll down, now we could actually search that. So as you can see here, we have captured this Bloodhound. Of course, you could scroll a further, just a few scroll down and you will find that. But the key thing here is that you have to be familiar with the script block logging and the common enumeration tools used by a PowerShell, which is Bloodhound, Sharphound, etc. Okay, so that's actually how we found this answer. So that took a while. Alright. So next one, so number 4, the attacker used encoded service path to escalate privileges. So what is the name of the vulnerable service path? So this is a pretty interesting vulnerability. So of course you have to know a background. What is this? So actually this is basically we are looking for services or that has a file name with a space in it, or does that have, it's not enclosed in quotes. So It's actually a vulnerability that allows attacker to execute something instead of that service. So as you can see here, ascent and close with coast leads someone known as unquoted service path. So it's a good read. Uh, so now we'll apply that knowledge of that in our Splunk search. So what we'll do here is still we'll keep the compromised host and the index, and this time we'll search in the image path. So for that, so asterisk.exe or in the command line or cmd line. Wait a minute. Oh, sorry, rather command equals asterisk.exe and then stats count by image and command line. Okay, so now this is our history here. So let's try that. Okay, still searching. Okay, my BM is quite slow. Alright, so now we have all the results. So it's 259 events. Actually, what can you see here? Anything that stands out? Okay, everything seems pretty standard. Windows stuff under System 32. Yeah, standard Windows processes. And actually, the one that stands out here is this one, the automate basic monitoring.exe. Alright, and that's actually the answer. Automate basic monitoring.exe. Alright. Okay, next up, what is the SHA-256 of the executable that escalates the attacker privileges? So practically we are looking for the hash of this service or executable. Okay, so what we can do here, we can scrap this part and we can add the automate. We can add it the search. What we can do here, I'll just copy it. Okay, let's scrap this for a while so I can show you what are the aggregated fields that we can see. Since we're looking for the hash, is there a hash field? And indeed there is, so let's add that in the stats. So hashes. Alright, so we are down to 6 events. So actually, as you can see here, this is not the answer, CEC, but rather the correct answer is the one with 8AC. Right here, oh sorry, it's SHA-256, so we are looking here, this one. So as you can see here, it's running under the guise of program.exe. But notice in the command line, it's actually launching this one. Automate basic monitoring.exe. Okay, that's how we found it. Alright. Alright, number 6. When did the attacker download fun.exe? Okay, so we found this. So to do this, so again, we keep the compromised source and the index, and we added at the fun.exe, and we use the reverse. So reverse command allows you to sort the events from oldest to latest. Okay, so let's show the field list here, and that's how we found it. 510 508 57. Alright, and next up, what is the command line used to launch the dsync attack? Alright, Okay, so for this one, okay, so this is sync. So you have to be familiar with here with the command line switches or syntax. So Dcsync actually has a Dcsync keyword in the command. So we could do a stats here, stats, image, command line, so that we could see. Oh, sorry, stats count by. Okay, let's give it some time, and it should return to us. Okay, I think I've spelled because you have to be aware. Splunk are case sensitive when searching for fields, so that's why we didn't get the result. All right, and what do we have here? So interestingly, so as you can see here, the fun.exe was used to launch the dsync attack. Okay, so as you can see here, LSA dump. So if you have been playing with Mimikatz, you'll encounter this LSA dump dsync user. Okay, so that's how we got the answer here. All right. Okay, so next one will be a fun one. So remember what I said in Q7. If you're familiar with this, you've encountered it somewhere using that tool sometime before. So, oh sorry. Okay, yeah, it's really Mimikatz. So sorry, I gave it away. So, so with here, let's do. So there's a field. Actually, I'll show you. There's a field that we can see that, and Splunk is parsing it pretty good. So if we'll just limit here, we could see here a field called original file name. Okay, so moving back, so if we'll command line, then original file name. Oh sorry, let's add again the fun.exe. And as you can see here, the original file name of fun.exe is Mimikatz. All good. So that's how we found that number 8. Alright, number 9, the attacker performed overpass the hash technique. So what is the AES 256 hash of the account he attacked? So as you can see here, we could actually use that command, that keyword AES 256. So to limit our search, or to narrow down the results. And oh sorry, pretty good. Yeah, we can still include that. So as you can see here, AES 256. That's how we got the answer here. AES 256. So okay, it starts with FAC 379. Okay, not this one, but rather AES 256. And this one. This one is the one the attacker used. FAC 379. Of course, you could test it out each other to get the answer, but that's how I get the answer. So of course, I've tested each result, but imagine we are able to narrow down to 50,000 events in this collection down to 13. And there's really, out of this 13, there's really just a few that contains AS256 values for us to be able to capture the correct answer. Alright, so that's the power of Splunk. Anyways, moving on. This one, what service did the attacker abuse to access the client 03 machine as administrator? Okay, this interesting one. So the attacker now moved laterally to client 03 using the account administrator. So what we'll do here is we add client 03 and we add administrator here. Okay, let's remove this and let's put time. What do we know? Okay, as we can see here, the attacker use this command line. And what service can we see here? Remember, port services, right? So port 80, HTTP service. So as we can see here, HTTP client 03. And that's actually the answer. HTTP service. To move laterally to, so clever, right? Clever technique. So the next one, client 03 machine spawned a new process when the attacker logged on remotely. What is the process name? Okay, for this one, so take note of the time when the lateral movement happened. So this time, we will limit to client 03. And we'll limit it to the time 510/2023 6/18/19. 510 date time range 510 May 10 2023 5:16. Oh, sorry, copy that. 6/18/19 6/18/19 6/18 sir 6/18 18. Okay, that would be good. Oh, apply. Okay, I think we narrowed the time pretty tight. So let's move it somewhere. So let's extend the time range 30. Okay, and look at all the noise from the Splunk. So let's negate some. What are the noisy ones? Not Splunk, because those are benign events. Okay, let's remove the Splunk. Alright, so now what do we have here? So again, new process. What's the process name? So we have few options here, and actually the correct answer is WSM probe host. So that's how we got the answer. Okay, cool. So next up, the attacker compromised the IT support account. What is the logon type? Okay, attacker. So again, going back to client 02. Okay, let's explore the data we have there. So okay, so and don't forget, we are dealing with a successful logon. So 4624. So you have to be familiar with this event. And okay, I'll show you 4624 for logon types. So this one is actually successful logon, and the interesting part for this event ID is that there are certain logon types. So here it's pretty much documented here. So we have 0 system to interactive to network and so forth and so on. So if you have remote, you have 10 and so forth and so on. So it's good to be familiarized with this one if you are working in a SOC or DFIR related fields. So having said that, so there's another field here aggregated for the caller username, so the account used. So client 02, oh sorry, I think we are still doing time, so let's move back the time to all time. Okay, I think we've limited the time range earlier, right? Okay, advance presets all time. Oh sorry, I think all time, all time, this one. All right. All right, so again, let's check the caller username. And what do we have here? Okay, we have plan 02, machine account. Okay, user account. And okay, so I'll bet this is the account with. All right, so let's use this. And with this, uh, we can now narrow down what logon types have been used. Because remember, right, help desk account, we have that as the answer earlier. So moving back, so if we are to observe the aggregated fields, there actually a logon type there. And what do we have here? We only have 9. Logon type is 9. So going back to our search earlier for 4624 logon. So 9 is new credentials, which makes sense because this is the attacker used. The attacker used to move to the IT support account from the help desk account. Okay, so that ties things up together. And last but not the least, so what ticket name did the attacker use to generate access to the parent DC as administrator? So this one, so we're able to find this. So okay, so moving on, so client 02, so let's add the ticket here and do a stats count by image command line time. Let's use this. And it narrows down our search to just 26. And as we can see here, when you are doing ticket attacks, of course you can also use Kirby, .kirby. So that's an extension for the tickets. And that's how we're able to find this one. So trust, where is it? This one, trust-test2.kirby, the very first result. Alright, so hope you learned something. And again, you see how powerful, easy to use, and intuitive Splunk is in dealing with investigating these kinds of attack. Okay, so until the next video, so see you guys.